Next up for you, we have the next mini track on observability. Observability, you can think of this as the fuel for automation. You want real closed loop automation, you have to be able to see what's going on with your actions. This panel session will be hosted by Richard Piasentin. Richard, the floor is yours.
Thank you very much. So good afternoon, everyone. I hope everybody is having a great conference so far. This is kind of unique. We're AutoCon 0, so we are the prototype. Observability would tell me that the bar is a very popular place, so that's good. Now, Insights is still on its way and coming, but we'll stick with observability right now. So if anybody's got a spare vodka rocks laying around, feel free to bring it to the stage. So what we're talking about today, as Scott outlined, is observability. And you have to be a member of the people that are in this room to really love observability, because observability by its very nature is complicated, it's domain specific, it's messy, it changes constantly. And it's vital to efficient, even human-based network management, let alone automated network management and the end game for all of this, which is the automated self-healing network. So it's actually the plumbing of everything that we do. And while I may not look like a typical plumber, I love, and I in this instance is not me specifically, but as a company, Accedian, we love the plumbing. Now, we also like the industrial design, and we can talk about that, but today, it's all about observability. It's all about understanding at a granular level what's happening inside of your infrastructure and being aware, and I'm kind of getting into my own talk track, and I'll come back in a moment, but being aware of domains of blindness that you aren't even aware you're blind to, right? So, you don't know what you don't know sometimes, and the observability game is the difference between success and failure. So, I am joined by an august panel here of gentlemen who know a lot more about observability than I do. And I'm going to ask each of you to introduce yourselves and talk a little bit about what you do and what your firms do. And then, maybe talk a little bit about why you're passionate about observability / network plumbing, which is my own personal version of it. Quick introduction. I was the COO of Accedian. As an independent 300-person company. We were recently acquired by Cisco. Our CEO is going off to do more plumbing elsewhere. I will be running the unit inside of the data center and service provider unit under Kevin Wallenweber, and I'll be driving the Accedian business inside it. Just a quick plug for Accedian in that construct. If you're a customer of ours today, just know and find me if you have concerns. I've done so many customer calls now, I get confused on who I haven't talked to. It is absolutely critical to Cisco, to Kevin, to DCPC leadership that we maintain an agnostic view of all of the vendor equipment in the infrastructure. So know that that's not an issue. So that's me. I'll pass it off to Josh Stevens from Backdoor. Josh.
Where's the on button?
Oh, yes. See, it might be on.
Is this on?
It is. Yes.
Well, my name's Josh Stevens with BackBox, and so 30 years ago, I joined the U.S. Air Force as a network engineer and cybersecurity specialist, and I've been building network management systems ever since. I think the first one was HP OpenView with Cisco Works and Cisco View, and a bunch of Linux CLI stuff I was doing way back in the old days. A few years later, some friends and I founded a company called SolarWinds, which we grew up and IPO'd and then sold later on the private market. I've been working at BackBox for about 2 years now, as an investor originally and now as CTO, and we are a network automation platform. I'm really passionate about observability because as a network engineer and someone who's been in this space for a long time, I'm passionate about the people that dedicate their lives to really changing the world. And when you think about the evolution of an IP-based network, a data network, and the technology that we take for granted today that wasn't available 30 years ago, It's really important to everything we do in our lives, from the phone on my watch that tells me if I'm having heart trouble, to my car that communicates back via satellite to a home office. Understanding how these systems are operating and when you have issues is really key. And so I'm really happy to be here today. Thanks.
Just jumping on that, this room has enough gray hair that pretty much everyone in here knows that the cloud actually has copper and silicon involved. So yeah, that's good. Thank you.
So I'm Justin Ryburn. I'm the field CTO for a company called Kentik. We actually are a network observability company. That's what we do. So I would say that's probably the main reason I'm passionate about it. Been in and around the networking space for 25 years. I went to college and got an MIS degree and thought I was going to be a developer, and then realized that I like people too much and I like solving the business problems, but I don't really want to write code for a living. I still find it interesting. I was actually talking to a former colleague of mine here at one of the last breaks about how I still every once in a while write some code, and like that high of endorphins that you get when you actually solve a problem with code. I'm like, oh, this is so cool. This is why I like coming back to this every once in a while. But I don't get to do it as much as I like to. Most of my day now is spent running around talking to people about challenges they see when it comes to observing their network, and how hopefully my employer can help with that. But if not, hopefully we can be part of an ecosystem that's building, as we're going to talk about here, some closed loop automation. So we're happy to be involved with this community and figure out how, with partners like BackBox and IP Fabric and Attentional, some of these companies who are represented here, we can help drive automation forward as an industry. So that's a little about me.
That's great. I gotta resonate with the I was an engineer, graduated as an electrical engineer, cutting code on OpenView originally, and realized I liked people, much more, and so got into the, wearing the vest side of the equation, whatever that means. And I don't know about you, but post 50, I've decided I don't really like people anymore. So actually, I'm coding again.
I was about to correct you on that.
Yeah.
Some people I could take or leave. But
yeah. Anyway, so last but not least.
Hi, Craig Johnson at Forward Networks. Last few years, I've been focusing on digital twins. This is what I do for Forward Networks. Worked on both sides of the equation, spent many years at Cisco, also as an operator as well, so I know the pain on both sides of the house. But yeah, for the reason I'm interested here is definitely on the automation side. Like, I've been working, my personal project, passion lately has been Terraform and Ansible, and how exactly we can, enhance that. And that's why I'm here at Forward. That's why I'm here, is to, what we can do with digital twinning and other, as everyone's talked about before, and see what exactly we can do to enhance this part of the industry.
I have to confess that I digitally stalked all of you, as one would expect, and I stalked your companies as well. And I have to say, the positioning around, I struggle sometimes to explain the difference between, what some service assurance platforms will do, where they're inferring. And honestly, I'm still struggling with the whole AI ops model and how that fits when you actually have to be deterministic about an outcome in a network. But leaving that part aside, the idea that all of our companies in some way, shape, or form, whether driving the subsequent automation, whether characterizing the deep details of the network, or building the digital twin of the network. I sometimes try to describe to customers, think of, if you're doing world-class multi-domain observability, you have effectively built a performance digital twin of your network that is causal, right? Or deterministic is probably more accurate. We all know that it's not 100%, but to describe the difference between inferring when you have a blind spot versus knowing how different parts of the infrastructure are performing, both are important. I'm not trying to say it's a one or the other. Right? And maybe we can talk about some of that as we go through. But knowing the difference is really important. So we have some canned questions. I'm hoping that even just the first question is going to strike up a conversation between all of us, including you all. And I'm assuming, Scott, we can leave 10 minutes for questions, because I really think, this group, I've been circulating a little bit, this group actually is solving the real problems. Again, forgetting about the VEST community. You're solving the real problems that all of our systems live to exist to serve. So just give me a 10-minute warning when we go in there. All right, I have some canned questions. I will start with them, and I want you to derail us completely because that will actually create an interesting conversation. So, number one, how does observability contribute to proactive and predictive network operations? Anybody want to take a shot?
I'll start. So I think in your intro, you kind of hit on this, right? Like, I don't think you can build a true network automation platform without having insight into how the network is currently performing, right? And that's where observability comes in, right? Providing that data, providing that input to say, okay, how is the network currently performing? Ideally, it's a closed loop, right? So also, once you see a change in traffic patterns, change in the performance of the network, being able to alert an automation framework, an automation platform that, hey, there's been a change in the environment, we should take action on this, we should alert somebody, maybe we can update firewall filters, maybe we can update routing policies. There's a number, depending on what it is, there's a number of different things you can do. So I think the two, to really build a good automation system, you need both, right? You need a closed loop between both observability and automation.
Do you mind if I pose you a follow-up question?
Sure, why not?
Okay, so I open with the idea that one of the challenges that we have in observability is knowing what we don't know. The flip side to that, and I'd be willing to bet, how many people in this room are engineers? Yeah, okay. So we have like a room full of analysis paralysis opportunity, okay? So as engineers, we love perfection, okay? So one of my challenges is, how do I advise a customer where the limit of observability exists? So how do you do that?
I don't know that I've solved for that one, to be quite honest. So if anybody's got a great solution for that, let me know. Yeah, I mean, I think, a lot like automation, it's chipping away at it, right? The only way to get on a journey is to take the first step, right? So I think we solve the things we can and continue to work on the parts of it that we haven't quite solved. Like, how do you observe certain parts of the system that are really difficult? Is there a data source for it? I mean, some things in a system, there's no S&P metrics, there's no streaming telemetry data, there's no model for it, there's just not a good way to get data about how certain parts of the system are performing, so it makes observing it really tough. But
yeah, absolutely, please.
I like that answer. I think to add to that, I would say that the limit of observability is oftentimes the point at which you can either automate or not automate the resolution.
Right.
And so when I think about the depth of observability and what it really gives you, when it's done right and you can automate some sort of resolution through AI ops, then you've got good observability. In most situations, though, what we find is that there's still a person at the keyboard at the end,
The make it so button.
The make it so button. Even if it's a big green button, are you sure? On your phone, you're sitting at dinner and your watch says, "Oh, the network's down. Yeah, I'll correct that right now."
Yeah.
And I think that is a big part of sort of what limits that today. And in many cases, what we find is that there are specific parts of that traffic pattern that you can't get observability down into. I was at reInvent a few years ago, and I had this guy come up to me and he said, I'm running a voice over IP service through Amazon. I'm getting packet loss inside this one specific area within AWS, and I can't solve it. They can't tell me why it's happening. It's not happening before or after. It's definitely happening there. They can't troubleshoot it. And as we build these new technologies, they become hyper complex.
Yes.
Multiple layers of NAT, containerized cubes with VPNs inside of them and virtual containers. So I think that the goal here should be to advance observability and automation together, so that they're making progress, so that you're getting a business value at the end of the day.
Yeah, I couldn't agree with you more. And I was just thinking to myself as you were describing that, it's like a successive series of 80/20s, right? Okay, let's solve a problem today, right? Okay, what is that going to take? All right, we can capitalize on 90% of for anybody that's a carrier in this room, I hope there's many, I have not yet met a service provider, and frankly, a modern enterprise, that doesn't find itself awash in data sources and a desert of insight, right? So how do we start, solve a problem, move to depth? I'm going to explore this concept a little bit more later, but you want to take a shot?
Yeah, I think Keon made the point yesterday. I think most people are afraid of the fail at scale problem, and I think the human problem is where we're finding the limit of observability. Like, it is if something goes wrong, there is an engineer there to fix it, and that's fine if it is 1 device, 10 device. It's not fine if it's 1,000 devices, and there's no way to correct for that. And while we still have humans in the equation, and while we still have that gap that we don't know what we don't know in there, that's where we're gonna, run into problems. And there's no closed loop for this at this point. We don't have. What I found is we've been a bit behind on the network side. Like in the software development sphere, there are unit tests. There are ways to test these sorts of things. We haven't created or we haven't integrated any of those sorts of infrastructure into our practice yet.
Well, and I think those insights that you mentioned are mainly driven by humans today. We give the data, and you're using not just the data that's present within the system, but years of experience, intuition, what happened last time you saw something similar, and that all kind of contributes to that. But I agree with you, Craig.
Yeah, there is still a little bit of a gap, and I think that is the AIOps challenge. Not that we're here to talk about that, but there's still a gap between, there's an observability sort of limit. You get to a limit of cost versus benefit, and then there's an insight limit, right? And in the end, we can't make 100% that causal connection between them. AIOps lives to solve it, but then it's anyway. It's an open set of questions. I'm going to move on through our canned questions. See what comes out. So. I think we've answered this one already. Is observability a key component of network automation? Can you in fact close the loop without observability? I think that's kind of an obvious question. The answer is yes, it's a key component, and no, you can't. I would change possibly the question just a little bit. You guys all have customers, right? I love customer wins, complex problems solved by a customer that lives inside of this question. Do each of you have an example that's your favorite one when you're talking to the next customer? Anybody want to take a?
Yeah, I think probably an example that I see a lot from talking to our customers around DDoS, right? Attacks against the network. This is one that I think as an industry I don't want to say we've completely solved for it, but I think we've made a lot of progress on it. So by being able to baseline the traffic in your network and look for deviations, again, a lot of the customers I work with still have that green go button, right? So they'll get an alert out of a platform like mine or somebody else's that says, hey, we think there's probably an attack, but before I go and say, yeah, I want to shut that down, I want to mitigate it, I want to black hole that traffic, or I want to filter it, I want to route it to a scrubbing center, whatever I'm going to do with it, I want to verify that that's not a false alarm. But I have worked with a couple of customers who've gotten a level of comfort with it where they're like, you know what? We actually have it automated first, and then it just notifies us so we can go in and look at it later. And we got to a level of comfort where we took the human out of that interaction, and we literally go from detection to mitigation, and it's fully automated and documented like in a ticketing system or a logging system, so they can go back and look at it later. But enough iterations of it, being able to be involved in it, they got to a level of comfort where they were able to completely remove the human for some of that. You
were talking, Josh, earlier about the make it so button, and then there's still that human. The idea that you're talking about here is somebody gets over the hump. That bridge to not having the button anymore is, your confidence in the number of times it's a false positive is low enough that and the efficiency gain is high enough that you say, I don't need the button anymore, right? I'll take the consequences of a false negative.
Well, and I think also when the consequences of leaving that situation as it is, like in the DDoS situation, versus the consequences of maybe making a change you didn't need to make, potentially causing a short-term, outage or something. I think that risk reward is part of the equation. The situation that I think about when it comes to this example is I work with a lot of MSPs.
Yep.
And while it might sound simple and straightforward from an observability standpoint, when you're managing CVEs and OS upgrades across tens of thousands of firewalls for customers on the remote end, and you're trying to understand, does that CVE really apply based upon the current configuration today? Does it apply based upon where that device is in the topology and the risk associated with that? What are the risks of doing an automated upgrade? Is it redundant? How do I route traffic around that? How do I understand traffic patterns during the upgrade and after? I think that's a good example of where you can do very simple observability, but at scale it becomes complex, and without that level of depth, it's very, very difficult to do that in a hands-free way. And part of why I like that use case is it's typically something that, we've all done. We've all donated nights and weekends to doing firewall upgrades. And I remember one time I missed
Even
a
in my own
playoff
house.
game between
Yeah.
KU and I can't remember who they were playing, but they lost that year, and I was at the Sprint Telecom headquarters in Kansas City doing an upgrade all night. And that's why I liked that part of a use case. I like to solve that and get people back their weekends. So that's where I think of.
Okay, great.
Yeah, I think the research side that you were talking about is really key. I think of a couple of my customers that, they get tens or thousands of weird IPs that come in on an IPS or a WAF. And you have to research those and say, okay, well, is that something? Where can this thing actually reach? That's it easily for one person to check just manually 10, 20, maybe an hour for each IP. That's an easy use case for why can't we have something that can do an automated pen test or some kind of system, maybe a digital twin, to actually check and see exactly where those things can go. Otherwise, you're having someone that's their job is just checking. Oh, we've got, even if it's not a full DDoS, just this is a weird IP I don't recognize. Is it something I need to worry about? Is it a 0-day, something like that? So yeah, I think that's an easy use case for Observability that we get to.
I can't help but feel that all of these examples, right, kind of bring us to an idea that there is there's a confidence level, right, which dictates the whole, again, and I think everybody in this room knows that, right? We're still at the stage of building the confidence to turn over our operations, right, to an automated use case. So let's step back. We all know that's an open question, right? Probably the people in this room have 80% confidence, and then in our leadership teams that we have to go and talk to, they have a lower confidence level. They still want that body that you were talking about, Josh. So let's step back, right? So the people that are sitting in this room, they know this is the observability track. They want to learn from us. Now, I'm not going to be able to help you learn something, but hopefully I can extract it from these guys. So I'm a network engineer and a service provider. I've been told by my leadership team, hey, we know that observability in all the domains that are relevant is important to the success of our AIOps platform, okay? I've got this task. Where would you direct somebody to, what are the best in class standards for how you define domains of observability and how you go and at least start extracting data sets? And I'm going to challenge you to try to answer that question without referring to your own company. That also, I'm going to challenge myself to that point.
I mean, I think you have to figure out what the use cases are that you're trying to solve for, right?
Yeah.
I don't think there's any, similar to network automation, there are some confusing terms, and I don't think as an industry we've done a very good job of breaking observability down into subcomponents. The only way I can today solve for that problem is like, all right, what are your biggest challenges? What are the biggest things you feel like you have blind spots? Like, let's start with the big rocks and work from there. Like, that's, I think the best answer I can give is you just got to figure out like what are the big challenges? Where's my team spending the largest amount of their time having to Craig's point, log into the devices or go and look at data to try and figure out this IP address. What is it doing? Where did it come from? Like, what are the time-consuming tasks that your operations team is spending their time on? And let's start with those. See if we can figure out a way to build an observability system around those or an automation to the troubleshooting. It may not completely take the human being out of the troubleshooting, but if we can at least have them come to the table armed with trace routes, pings, packet captures, dumps, whatever it is, a lot more information. And now they can say, okay, now I've got a lot more information. I can see because of the additional data that I've collected what the most likely root cause is. It's a lot better than saying, okay, I got an alarm that fired off this IP address, looks weird, and now I got to go do all that manual troubleshooting and log into all these other systems and figure out what the heck's going on, right?
Okay.
I love the question for a few reasons. Number one, it's complex and it's hard, right? And there aren't really a lot of good answers to the question, quite frankly.
No.
And what I love about this audience and this event so far is that whether you realize it or not, this is sort of the cream of the crop.
Yes.
Like this is the top 3 to 5% of people that are doing automation and observability in the country for sure, maybe in the world. And by and large, the conversations I've had here today are significantly more evolved than the typical customer I talk to and where they are, right? So first of all, well done. And I would encourage you as a group to remember that this is the time as an industry when we band together and come up with these standards and begin to define these templates and how we work around this. Many of us are transitioning from traditional NCM platforms and monitoring platforms toward observability and automation. And while I won't refer to our product with respect to the way you pose the question, Kentik would probably be my first call. Because I think that it's hard to find good products and good expertise around observability. Now, you can certainly find a services partner that can help you with that, but finding a vendor that will partner with you and has done it at scale is a big part of that success. I would also say, don't be afraid to start small and keep it simple. You can get some big victories that way, and keep in mind that the frequency of those simple issues typically is higher than the complex issues, so you can actually get a really great net savings in time by focusing on the things that you can automate now through observability. There are probably the things that are mundane and you don't want to deal with that will allow you to deal with the more complex things. But this reminds me of sort of back in the 90s when we were writing RFCs, and I think that kind of effort is needed now.
So the origin of the way I posed the question was actually to trigger a discussion around can we create, and I'm not good at processes and things like that, but can we create, or is there a need for a standardized view of to Justin's point earlier, what the hell is observability anyway? We all feel like we know what it is, right? But let's define it, right? Then second, color me ignorant, but a cloud workload serving a client across infrastructure is a fairly common pattern. And as an industry, we should be able to say, okay, well, if you're a grade A observability company, excuse the nomenclature, you will have done at least the following, right? Like a reference, model, template, pattern.
Not just a reference model, but I think you also need some sort of agreement on how those models will be used within the API set. If you're using our product and you decide to swap it out for iTential or vice versa, you shouldn't have to change how you're interfacing with a product like these products, right? And I think that today it's all very customized, it's all API driven, and you can do it, but there's a lot of elbow grease involved. And ideally, we'd like to get to a point where there's a standard model. You can apply it no matter whose product is underneath. And maybe you're using Ansible and Terraform, or maybe you're using BackBox and Forward. But I think we have to get there pretty quickly.
Well, I mean, obviously, because of the way I pose it, I believe we do as well. We're right at that point where the fundamental technologies by domain are accessible. Okay, I don't know if you guys would agree with that, but I'm not sure there's a domain that engineer couldn't figure out how to access data sets. It's the cost reward, and then what is industry best practice in that construct? A basic one, right? I won't mention our products because I said I wouldn't do that, but there's a huge difference between discontinuous test and continuous characterization. Well, at a basic level, I mean, what's good, what's bad, just those standards. So I'll stop. You haven't had a chance to pile on here.
No, and I think that's kind of key is I don't think we're going to get away from that continuous model. Like I think a lot of us still work with old gear and we still have to deal with it. So there's really no getting, so I don't see us getting to, I guess we're getting towards some kind of standard. I don't see that as a thing. These things are going to continually evolve. And so I guess I'm just not seeing a panacea that we're going to get to, that this is the place we'll be.
I agree with you in the construct of building an RFC to do this. I'm not sure we can get there, but if, every one of us goes on a YouTube channel to figure out, hey, tips and tricks on how I can do the plumbing without having to wait for the plumber to come to the house. Even if we just had, and maybe this is what the AutoConf space lives for, is a little bit of a standardization is probably a bad word. It's a community of interest around, hey, can we pool our learnings? If I guarantee you, from an observability perspective, if the four of us documented our top 10 solutions in observability, it would help 85% of the people in the room. You know what I mean?
Sure.
All right. Add,
the only thing I was going to add to that, I think the problem that I have with your analogy of the plumber in the YouTube video is fundamentally plumbing hasn't changed in 50 years. I mean, sure, copper's moved to PEX. I mean, there's been some innovation, but it's not nearly as complex and changing as frequently as networking is. I mean, you look at like networking in the cloud and VPCs and transit gateways and all these things, like for those of us who are classically trained network engineers, there's all these new constructs that add a whole nother level of complexity that we've never had to deal with, which now we have to figure out a way to observe in a programmatic way so that we can feed into an automation framework. I mean, that's a much more complex and constantly evolving situation. It's really hard to build best practices. By the time we would all sit down and write them and say, this is how thou shalt observe a network today, someone's out there changing it on us, right? So it's really, I think that's part of the challenge that we face as an industry is, the answer is it depends, right? the
it depends. And then the follow-up is, if you're one of these 4 companies, trust us, right? So,
and I think that's right. You can have a really good understanding on very specific domains. Like I can be really sure how my particular EVPN fabric forwards, or really sure how forwarding happens in this region of AWS or whatever. When I start to expand that, that's when it gets way too big for one human or even just a team of humans to really. And at the same time, your analogy there, the plumbers, they build up to a code. We don't have a code that we build up to.
Yes, and please excuse me for my metaphor, right? It was just to describe the idea.
It works well because it's like they have their RFCs that they build to. We don't. We just do what we want. Yeah.
And we all think we could do it. Yeah. We do have 10 minutes. Okay. I will pose a speed question. Okay, so pick your favorite domain of observability. And these poor guys, these are not on this page. Your favorite domain of visibility, again, thinking about your customers. And what is an important resolution of data set? What is in that particular domain that you've worked in, what was that particular KPI, and what was the resolution that was required for a proper observability and then to feed in an automated work case? I mean, I'll start with an example if you want. All right, so one of my favorite ones is, and this is a little bit of an old one, but the augment of LTE networks was the first time that voice over the mobile network had to be carried in a voice over IP packetized form. So again, a non-dedicated channel, essentially using basic IP technologies to get a continuous signal, which is obviously our voice. And oddly enough, at least at Accedian, we have discovered that humans are really good at detecting packet loss. Okay, oddly enough. All right, especially our spouses and our home networks, and I know everybody in this room knows what that looks like. Leaving that aside, one of my favorite examples was the requirement to have a resolution when you're monitoring the backhaul network for the mobile network to be able to detect a ring switch. So having a high enough resolution in the domain of the backhaul network so that you could detect a 20 millisecond ring switch, because that would materially impact end customer experience. That's one of my faves.
It's like interesting problem. So I was at KubeCon last week in Chicago, and I was talking to some people, and one of the challenges that one of our booth visitors posed was they have orchestration that will spin up additional containers if CPU and memory on the existing pods hits a certain threshold. Like that's built into Kubernetes, that's pretty easy to solve for. The problem they don't have is, what happens if I saturate my network? Like that's not a metric that their current orchestration system is monitoring. And so they're like, all right, how do I observe the network traffic, figure out when I'm getting to a threshold where I may not have exceeded CPU and memory of that pod, but I've exceeded the throughput of a given pod so that I can spin up additional pods. I just thought that was a really fascinating combination of network and modern microservices deployment that I hadn't heard before.
A virtual network infrastructure is
the network
blocking.
Does actually matter, as it turns out, in the cloud. It's still there.
Yeah, right.
It hasn't been abstracted away.
Yes.
You kind of stole my thunder. That's exactly what I was going to talk about, because I think in those environments where you've got tubes and containers and it's all remote in the cloud, it's so difficult to troubleshoot those environments. And we take for granted nowadays that there's always going to be available bandwidth, the network's going to be always on and available, but
that's the key point.
It's not. In many cases, it will be saturated, and unfortunately, a lot of the younger network engineers on the teams haven't really dealt with traffic congestion issues. They don't know how to do traffic shading. They don't know what weighted fair queuing is. It's a whole different ballgame, and so it's one of these scenarios where it proves that you do need the fundamentals, even in a modern environment. and it'll carry you a long way. So that's kind of what I was thinking too.
I find the biggest challenge that I find with the teams that I work with on the network side is even still today, they don't know, and even the application teams don't know what the applications look like. And when they make changes, they really don't know what they're affecting. And I found some good innovations with some companies that have done some mapping. You know, we've gotten better on, you know, observability and NetFlow and IPFix. And so I found some good ways that has at least gotten some level of data, whether maybe it's just top talkers or something. But I found that's to me, that's the primary problem that I've seen is, yes, I can tell you that the network seems to be functioning correctly, but if I have 700,000 routes and I miss one because that happens to be some application that happens to be halfway around the world, how did I catch that? It's that level because I don't actually know what the applications and the talking is going on my network. So some of the tools that I've seen on that area have been really worthwhile, at least to be able to say, you know, instead of having, you know, 300 people on a call on a change window on Friday night to check every one of their applications, to at least have some mapping of those. I've seen some good solutions there.
You want to bring this full circle, that's where observability can help, right? I mean, that's a fairly common use case that we hear from enterprises that are migrating applications from an on-prem data center to the cloud. They're like, I go and ask the application people, okay, what ports do you need to have open in your NAC or in your VPC in order to allow this traffic? And they're like, I don't know.
They ask you what a port is.
Right, exactly. I have no idea what that even means, nonetheless how to answer that question, right? And if you can get some sort of observability system that says, okay, in the data center, this is what's talking to what, like I can map that all out, I can see what all that looks like, then I can plan those migrations much better, make sure that my firewall filters are updated correctly as I migrate to that application to the cloud.
And if you can't do that, then you're stuck with a VPC that allows everything through, and you know you might as well leave the back door open.
And you're you know pouring money into AWS, okay, which none of us want to do. If there's anybody here from AWS, I apologize.
There's a headline on Monday morning, yeah.
Yeah, but I still mean it. You know, I would just say, and I want to open it up for questions. Now we have some mics here. I don't know if anybody's got some questions. You know, does anybody have any questions? 1, 2, 3. Okay, maybe another thought related to observability. Oh, is there one over there? Okay.
Yes. Hi, Will Baumann. I have a question to OpenTelemetry. How do you think that the network fits into OpenTelemetry?
It's a great question. I have a view, but
I'm kind of interested to hear your view before I answer.
well, we're big, you know. Okay, but this unfortunately has to be an Accedian plug, so apologies.
We'll allow it this once.
Just once. Okay, thank you. I appreciate it. And now a Cisco plug. OTel, from our perspective, is the right path to go down. If you look at multiple systems inside of Cisco, independent of us, OTel is becoming the de facto standard for extracting data sets. Network information needs to be part of that. Our native ingest format for all of our telemetry is open metrics, which is, as you know, is a subset of the OTel standards. So personally, and our company's position is it's a vital component of how we do observability. And it's a good way to get to a somewhat standardized way to do it that was mentioned earlier.
And I would add that nowadays with 5G networks, you can have an out-of-band telemetry network that's very reliable and high bandwidth. So there's really no reason that you shouldn't be able to ship that data back and have it available when you need it. And,
Yes.
and you know, that is such an advantage over yesteryear when we didn't have that available.
No.
But you can put a remote power management console manager with a 5G card in it and run a telemetry network for all your devices that makes that data ultra reliable. And you know, if you're investing in observability, you need to invest in making sure you get the data and to make it useful.
I do think OpenTelemetry is going to provide us some value there and being able to have, like you said, a standard format for shipping this information around, everything from what does it look like on the line to what are the types of metrics that we're collecting. I think there's some interesting work being done as part of the OpenTelemetry group, so I'm kind of excited to see where it goes.
We're big advocates for self-describing protocols as well, right?
I agree.
You know,
Hi, Anthony Nelson. Richard, I really agree with you on the whole standards approach in the sense of, right, we're only going to be better as we build on this and build on each other's work, right? So we're doing a lot of automation, a lot of good work in a lot of different silos, and some of it's getting released, but it's still really kind of in this solid approach, and observability is no different. So can we, reference architectures, or, can we, here's how different technologies you can put together as a forum to say, all right, you want to get into telemetry or observability, here's some key components as a group that we recommend back to the industry.
I mean, that's kind of why I posed the questions the way I did, because I just feel like we're at a point right now where it's too early to RFC it, but it's past time to have a community of interest. We've been talking about automated networks and self-healing networks for a really long time, right? As long as I have been involved in networking, and I will not tell this room what that is, we have been talking about this, but we're right at the moment where you talked about it at the beginning, all the boxes have the friggin' levers. All the boxes have the blinking lights and the data feeds. It's now up to us, and one of you made the comment about the cream of the crop being here, it's now up to this community, to actually do what we've been talking about for 30 years. And I just aged myself right there. So, yes. So I leave it to Scott and the rest of the team and all of us to make that happen. So that's a great spot to possibly end. We are at time. I hope this was of some interest to all of you. Complicated subject, all that kind of good stuff. Gentlemen, I appreciate you humoring my random approach to panel moderation. And thank you very much for your time today. All right.
Thank you.
Cheers, everybody.
Thank you.
Yeah, good, yeah. Thank you. Well done. Cheers. And I only mentioned Accedian once.